Hi, everybody. I am going to take you through our lesson 11 note and sort of, what you need to do so that you have all of the concepts for lesson 11 taken care of in your summary notes and in your practice today. So here we are under content. All right. So we're in the content section. You're going to go into unit 1. And you're going to scroll down. Oh, look at all the things that we have done. Okay, lots of different lessons. And you're going to click here on lesson 11. Okay, so you'll be able to come in here and click on what do I do? And when you click on that, there will be a resource note that you can access. It's also right here, okay, under what do I do? And then you can also click on the summary note. Okay, so I'm just going to kind of toggle around here. Here is the summary note for you. And again, it's up to you. You can print this off. You can, it'll make a copy of this for you for Google Docs. You can type right on here and then print it off. It's totally up to you how you want to manage yourself in the course. And you already should have a system. Okay, and if you don't, it's time to get one, because we do have the final assessment task for this unit coming up, and you need to have all of these lessons handy. So you're going to go through and you're going to answer all of these questions here. And there's quite a few things that we need to do. And you're going to find all the information in your main resource note. Okay, so you can click on the link here. You can click over here under content. I'm going to open it up. And again, if it was me, I would be making this full screen. And then down we go, reading through, some of our Catholic expectations, if you're Catholic. And then right here are some interesting tests that they talk about for certain drinks that we buy, such as milk, such as tap water. And just notice, that the title here is Solubility of Ionic Compounds. So we're now doing a little lesson on solutions. But this little lesson is going to incorporate double displacement reactions and balancing equations and coming up with formulas. This actually is quite a large lesson in terms of, some new things that we learned, but it also it ties together several of the concepts that we've already learned. So you're going to read through this. You're going to make some notes on that. Here again, solutes, solvents, and precipitates. So read through this. You're going to make notes on this based on the summary note, the questions that I ask you to do. And what we're doing here is we're talking about, solutions and things that dissolve in water. So right here, when we put a tea bag in water, for example, parts of the tea leaves will dissolve in water. And we know this because there's a color change and flavor compounds go in there. You know this because you know that your tea changes its flavor. It doesn't just taste like water anymore. But there's a bunch of components that don't dissolve in water. And, when these things don't dissolve in water, what do we do when we're dealing with chemical reactions? So here's an example of a reaction. They took a potassium iodide and lead 2 nitrate, and these are both chemicals that dissolve well in water. But once they put them together, they formed what we call a precipitate. And a precipitate is a solid substance that forms that does not dissolve in water. So what do you do in these situations? Okay, especially when you're expressing them as a chemical reaction. So all of this background here is you're going to deal with this in the summary note, especially here, how does salt dissolve in water, for example. And then I want you to watch this video. Okay, these are really, really good videos. It's only 4 minutes that shows how substances dissolve in water, whether they're ionic or whether they are covalent compounds. And then we're going to move into something called solubility rules. And this is a really, really important concept. And there's some interesting info here about, again, things that dissolve or don't dissolve. But this chart right here is really important because you're going to be coming back to this chart and using it to answer some questions, but also to complete the final little project in Unit 1. To complete the final test in Unit 1, you're going to need this solubility table. And what this table does is it lines up ions. Okay, so remember that we have positive ions and we have negative ions that come together and form an ionic compound. And depending what those ions are, they're either going to be soluble in water or they won't be. So remember that soluble means they dissolve. Okay, so you don't see them floating around. It's like salt. Salt dissolves in water. And actually, if I said to you, does sodium chloride dissolve in water? You can come over here and you can say, oh, sodium is an alkali ion based on the periodic table. It's an alkali metal. There it is right there. And if I combine sodium with pretty much any other ion, okay, any other ion like chlorine, it will dissolve in water. Okay, and that's what soluble means. If I took something like chloride right here and I combined it with a silver ion or a lead 2 ion or mercury 2 or copper 1 or thallium, then it would not dissolve in water. And that's what insoluble means. So just with these 5 ions, if you mix them with chloride or bromide or iodide, those substances would not dissolve in water. And you'd see them floating in solution. You'd see them. They don't dissolve. But if you had any other positive ion, like sodium, for example, okay, so sodium plus the chloride ion or the bromide ion or the iodide ion, it would be soluble. Okay, so what you do is you match up the combinations and then you determine, is it soluble or is it insoluble? Okay, this is a really important chart and it's a good way to figure out whether things dissolve or not. So here's an example using the solubility table. Is calcium chloride soluble or insoluble in water? And then the note takes you through all the steps, sort of like what I just did, and explains to you whether it should or should not be soluble. Here are 5 for you to try. You've got the chart in the summary note for you to do. And then we start to get into double displacement reactions because this is where we need to be checking the solubility chart to see if we form anything interesting on the product side. Okay, so when you have a double displacement reaction and you combine 2 substances, if the products that you make are both soluble, okay, and soluble means aqueous, okay, aqueous means right here, it says, first of all, reactants are in the aqueous state, which means they are both dissolved in water. Well, if they dissolve in water, that means they're not making anything new, okay? They were dissolved in water to begin with. So if you notice that everything is soluble, we actually say at that point that a reaction doesn't occur. It's only if we make a solid or if you make a liquid or a gas product that we say a double displacement reaction actually occurs. So down here, this is where predicting double displacement reactions, you need this solubility chart. So it says when 2 aqueous ionic compounds are mixed together, one of 2 things can happen. So nothing could happen. You could mix 2 substances together, 2 solutions together, and then you don't see any chemical change. You don't see anything new being formed. Or you'll see a solid being formed. Okay, and so when the solid is being formed, if we just scroll back up, that's when we see something like this start floating around in solution. Okay, and then we know, well, one of the products that we made was a solid. How can I tell who the solid is? This is how you can tell. You can look up the combination of ions and determine who was insoluble, and that would be the solid in your on your product side. Okay, so what we want to do is we want to get you thinking about what reactions would occur and what wouldn't. So here's an example of a reaction. And, how do we do double displacement reactions? Well, remember, outside ions go together. Aluminum and phosphate will make one product. Sodium and nitrate will make another product. And then what you can do is you can go up to the solubility chart and you can determine whether those combinations of ions is going to create a precipitate or not. Here we go through examples. So watch these videos. They take you through the examples of how to come up with the products and how to come up whether the substances dissolve or not. And here's another example as well. A few examples for you to try. Lastly, what we do is for any double displacement reactions that do form a solid, we really are only interested in the ions that make that solid. Okay, so notice over here, like sodium chloride is salt solution. AQ means aqueous. That means that it's dissolved. And we really don't care about the ions that are dissolved. We care about the ions that formed something new. And you can see that your reactants were dissolved initially. And when we combined them, we formed some more products that were dissolved, but we formed this product that was a solid precipitate. So I really only care about the calcium ion that came right here and the sulfate ion that came from that reactant. Those are the only ones that I really care about in this overall reaction. So I want you to read through and understand sort of what we do, what are the steps that we do to just deal with the ions that make up that solid substance. We don't care about the sodium and the chloride because it doesn't create anything new. So here are the different steps for you to follow and to go through. And it'll show you there how we separate everything into its ions. Okay, so this is where your periodic table has to come in handy. You have to have your periodic table nearby. And then watch this video here. He does an excellent job of going through total and net ionic equations. You'll see these two reactions are posted on your summary note, so you can give those a try. And then you're going to stop there. So when you see consolidation here, you can stop. That is the end of our lesson for today. And try some of the net ionic equations. Let me move back here. Here on this practice problems worksheet. Let's load that for you. Okay, and so you can go through and they're telling you to show the complete ionic and net ionic equations for all of these, okay? And you have to come up with the products for some of them. Here's some, brief solubility rules if you want. I would probably go back and I would use that chart in the resource note. It's pretty good. And then here are the answers for it. So, I'm going to tell you folks, the net ionic equations can be a bit tricky. So do make sure that you carefully read the note and that you go over the examples that they give you. They give you lots and lots of examples here in the main resource note. And make sure, so again, when we get down here to net ionic equations, they give you all kinds of examples on how to come up with the products, come up with the different ions involved. Do make sure that you look it over. If you need help, reach out to me and we can try to set up a Google Meet. But this is what we're going to have you work on for today.